We're going to get started. I'm going to go over this week's lesson, but before I do that, I do want to review something that I saw a lot of struggling with on the past week's lessons. So let me get my camera set up for that. Put this up on the screen. Oh, let me remind you guys, tomorrow is parent-teacher conferences. So love to see you guys and bring your parents up. We are located in the Bentonville High School building. You see, when you turn into Bentonville High School, you'll see Virtual School and Gateway. We have our own entrance there. So come see us. Bring your parents. It's tomorrow from 4:15 till 7:45 in the evening. So I'll be here all day tomorrow. I ain't got anything better to do. Let me chat with some parents. That'd be great. All right, I want to review this real quick. This is from previous lessons. And so I have just illustrated a function here. And we seem to really struggle when we talk about intervals of increase and intervals of decrease. So let's talk about what an interval is. An interval is, well, just talk about this. When are you going to eat dinner tonight? What's the interval of time that you're going to eat dinner? Well, I'm going to eat dinner from 6 to 6:30, Mr. Brock. Well, that's the interval. It starts at 6, it ends at 6:30. You're giving me an interval of time. So on these problems, it says, what is the increasing interval and the decreasing interval? So let's look at this graph. Interval always starts from smallest to largest. You didn't say I'm eating dinner from 6:30 until 6 tonight. You always start with the smallest number when you're defining an interval. So we would start down here with the smallest x's. So as we look at this graph, it's increasing, it's increasing, it's increasing, it's increasing. During this whole interval of time, this graph is increasing, still increasing until this point right here. It stops right there. And let's give that a value. Let's say that is about negative 1.8. And the y is 4. The 4 is the value of it. That's how much it increased to. It started down here at negative infinity, and it kept going up and kept getting up and kept going up and stopped when it got to 4. Then what happened? Well, then it started decreasing. Now it's a decreasing function. Decreasing. Decrease. And this thing decreases all the way until it gets to right there. So let's give that a value. That's about 2.2 and negative, let's say 1.7 for the y value. So it was all the way up at 4 and it decreased to 1.7. That's not the interval it decreased. This is the value, how much it decreased. It went from 4 down to 1.7. It decreased 5.7 in value, but that's not the interval. After this point right here, it starts increasing again. And we see it increasing and increasing and increasing, apparently all the way to infinity, because that arrow says it's not going to stop. So what is the interval? Let's talk about the interval of increase. There's 2, because here's one and here's one. There's 2 different intervals. So what marks the boundaries of when it's increasing? Well, this end is negative infinity, right? Because it starts the smallest possible x, negative infinity. It starts way out here, and the whole time x is getting bigger, this graph is going up and going up and going up and going up. It starts way down there somewhere. And so that interval starts all the way out at negative infinity, and it keeps going. The x's are keep going, keep going. Oh, stop. We stop when we get right here, because that is the end. Oh, I got the wrong pen. That is the end of the interval. So this is increasing from the interval of negative infinity all the way until it gets to negative 1.8. Interval. Increasing interval. I'm going to put increasing. That's an increasing interval From the time this graph is all the way to negative infinity, and you keep following all the way until it gets to negative 1.8, because at negative 1.8, it stops increasing. And in fact, at negative 1.8, it is not increasing nor decreasing, because that's where it's flat. So don't put a bracket here. It does not include 1.8, the negative 1.8. That's not included because it's flat at negative 1.8. So the interval is the x values. You're giving me the boundary starting here and ending here for all of those x's. This is increasing. But however, we said there's two increasing intervals. So it also, starting right here, starting at 2.2, it's also increasing, and it increases forever. This is a second interval of increase. Oh. A second interval. So there are two increasing intervals. And this is the boundaries. This is an interval. This is the beginning and ending place. It starts at 2.2 and goes all the way to infinity. That's the beginning and ending of this interval that's increasing. This one starts at negative infinity and goes all the way till it gets to negative 8. That is the interval. Interval, you tell me, where does the interval start? Where does the interval stop? Now, in between there, so this was the other increasing interval right there, right? Starting right there and going forever. In between there, the graph decreased. It started at 4 and decreased down to 1.7. So what's the interval where that happened? Well, when x was right here at negative 1.8, it started decreasing, and it kept decreasing all the way until 2.2, where it was flat once again. So the decreasing interval, where does it start and end? It starts at negative 1.8. That's where the decreasing interval started at. See right there? It started, and it kept going all the way until 2.2. That is the decreasing interval. So don't get confused with the y. Just says what the value is. If this y was 4, that means it'd be up here. It wouldn't have increased or decreased. It just stayed flat. But it decreased from 4 down to negative 1.7. Oh, really? When did that happen? Oh, well, between negative 1.8 and 2.2, in between here and here, it decreased. It went down. The y dropped. But after that, the y started going up. That's an increasing interval, starting at 2.2 and all the way to infinity. So hopefully that clears some things up for some people that were confused about intervals. An interval is always defined by starting and ending point. Even when the ending point's infinity, that tells us it goes on. But an interval of anything, interval of time, that's a starting and stopping point. What is the interval of time? There's lots of things at intervals, but we seem to think of it differently when we get on a graph and with a function. We don't know what to do with the interval. So, all right. Let's look at our lessons this week. We're going to be doing factoring. Now, we did some factoring last week, but this is all about factoring. We're going to get a good reminder on factoring. I know you factored in the past, and we're going to have a lesson all about factoring and solving by factoring this week. So 4.3, factoring. So the first thing in factoring, look for a greatest common factor. Greatest common factor, something you can factor out of every term in the equation, or the function in this case. So if we look at this, 12 and 10, well, we can take a greatest common factor out of that. We can take out a 2. That's the largest number that goes into both of those. And then we've got a to the third power and a to the second power. So a to the third power is a times a times a. A squared is a times a. They both have 2 a's. They both have an a squared. So we can factor out a squared. So when we factor out 2a squared from 12a to the third, we're factoring 2 out of 12. That's times 6, right? 2 times 6 is 12. So when we divide the 2 out, it leaves 6. When we divide a squared out of a, what's a to the third? What's left? Just that, just an a. We had an a left. So that's factored 2a squared out of 12a to the third. Plus, we still have to factor out the second term here. We take 2 out of 10. That must be times 5. So 2 times 5 is 10. So when we divide, we get 5. A squared. If we factor a squared out of a squared, that's just 1. So 5 times 1 is just 5. So this is the factored equivalent. 6a plus 5 times 2a squared is exactly the same as that. It's just factored. And this can't factor any farther. Let's look at another example here. 14 and 7. Oh, we can take 7 out of both of those. M to the 8th and m squared. We can take m squared out of both of those. N to the 5th and n squared. We can take n squared out of both of those. So what's left? When we factor a 7 out of 14, there's 2 7s in there. When we factor m squared out of m to the 8th, that leaves m to the 6th. That's still left in there. N squared from n to the 5th is n to the 3rd. So that's all of the first one. Now minus what's left. 7 m squared n squared. We factored it all out. When we divide this by this, we just get 1. We factored out the entire term. There we go. 7 m squared n squared divided by 7 m squared n squared is 1. So that factors to that. All right, let's look at example of difference of squares. So perfect squares would be like a squared minus b squared, right? Where both terms are squared terms. So the rule is when you have that, you can factor that as a plus b times a minus b. And that's how it factors. If you have 2 squares and there's a subtraction in the middle, subtraction, because that's what difference means, take the difference between the two, you can factor it like that. So let's look at this. Is this a perfect square? What can we multiply by itself to get 9x squared? Well, that is the same. We can go ahead and put the terms as 3x times 3x. That's a perfect square. 9x squared. Negative 49. So that's the difference. We have the difference. 49y squared. Well, that's the same as 7y times 7y. So that means if we do a plus on this one, a minus on this one, that's how it factors. We just took the square root of both of those perfect squares. All right, let's try that again over here. On this one, we're like, 72 is not a perfect square because that's 9 times 8, right? That doesn't work. And 2 is not a perfect square, but we're going to remember the first thing we do is look for that greatest common factor every time. So if we factor this, we can take a 2 out of it. 72 divided by 2 is now it's 36. C to the 4th, and then factor 2 out of 2, and it's just 1. So that factors to 2 times 36c to the 4th minus 1. These are both perfect squares. So this would factor to 2 times, and what are the 2 squares? 36 is 6. 6 times 6. C to the 4th is the same as c squared times c squared. Then we'd say plus 1 and minus 1, because 1 times 1 equals 1. So we can factor that to this. We just have to take that greatest common factor out first, which was just a 2. That's the only factor it had in there. All right, let's look at, I don't want to do all these. It'll take the whole hour and a half. So we're gonna skip around. I'm gonna skip this one and jump over to this one. So this one, we can obviously factor a 10 out first, and there's a W in each term. So what's left? Well, I take the 10 divided by 10, that's just 1, which we can put the 1 or not, but W to the 5th power divided by w is now w to the fourth power minus, well, if we factor 10w out of 10w, that's just 1. So I've got 10w w to the fourth. It's 1 w to the fourth. It's just w to the fourth. So this would be w squared plus 1 minus 1. So it kind of works like the one above it. We're just able to pull a w out this time, and that leaves us with a nice square. As long as this is an even number, you can split it in half with that exponent, because when you multiply exponents, you add them. So you just split it in half. All right, let's do some trinomials here. Again, I'll pick like maybe 4 of these to do here. Let's start with this one. Now, when we're factoring a trinomial like this, we need a number that multiplies together to be negative 24, multiplies, and adds together to be the middle one, which is a plus 2. Negative 24 and plus 2. So let's see. Negative 24, that would be negative 1 and 24, or 1 and negative 24. Or we could have negative 2 and 12, or 2 and negative 12. Or we could have negative 3 and 8, positive 3 and negative 8. We could have negative 4 times 6, or we could have positive 4 times negative 6. And that's it. So that's all the combinations of numbers that we can use, because that's the only way to get 2 numbers together that multiply together to be negative 24. But which of these add together to be a positive 2? No, because this is 23. That's negative 23. Add those together, that's 10 or negative 10. Add these together, it's 5 or negative 5. Add these together, oh, it's 2 and negative 2. So the 2 is this right here. So split the n to the fourth. We can take that's n squared. And n squared plus 2n. So we're going to say this one's minus 4. That's n squared. So that's minus 4. And this one's plus 6. So we got n squared minus 4 times n squared plus 6. And when you multiply that back together, it would be this. But if we're paying attention, this is a difference of squares. So let's take this first one, because that one can't factor anymore. But we can take this as n times n and 2 times 2 with 1 plus 1 minus. That's different squares. So this factors to n squared plus 6 times n plus 2 times n minus 2. Whew. That's a nice thing. Now, you could break this down, but you wouldn't have regular numbers. You wouldn't have whole numbers. So we stop factoring when we run out of whole numbers there, because we'd have to use the quadratic equation to figure out what that factor would be, because it's not a difference of squares, and we can't factor anything out of either term, so we're done with that. Let's look at this one over here. This is a little different. We got a w to the third plus w to the second minus 20w. Well, the first thing I see is we have to go back to the rule number 1. Does it have a common factor? Yes, it does. So we take out a w because it all has a w. So that leaves us with w squared plus w minus 20. So now we're back to what multiplies to be negative 20, but adds to be 1. Well, negative 20 would be negative 4 times 5, and that adds together. Negative 4 plus 5 is 1. So this would be w times w minus 4 times w plus 5. Now notice when we factor it, since this was an n to the fourth power, this was a w to the third power, the largest exponent. This is a w to the fifth power. You should have that many of that exponent in your answer. W to the third power, a W, a W, a W. We should have 3 W's. N to the fourth power, we should have 4 N's. There's 2 because it's N squared. 3, 4. We have 4 N's. Fifth power, there's a W. There's 2 W's because it's squared, and there's 2 W's. So we do have 5 W's. We didn't lose any. We still have all 5 that we started with when we factor. So that's kind of important there. All right, let's look at this one. This looks like a mess. But again, rule number 1, we can pull out a 2 and an A. They all have an A. So if we factor 2A out of 2A to the third power, that gives us A squared. If we factor a 2A out of 38A squared, that leaves a 19A. And 68A, the A is going to be factored out to be a 1. 68 divided by 2 is 34. All right, so we need 2 numbers that multiply together to be 34 and add together to be 19. Oh. Well, the first choice we got would be 2 times 17. That adds up to 19. So 2 and 17 is our answers. 2A, A plus 2, A plus 17. 3 A's in our answer. A to the third was where it started, so we should have 3 A's being multiplied by each other. A times A times A. All right. Let's see. Do we need another example? Well, let's move on. The next part is also factoring, but we're going to take it one step farther. Let's look at 4 terms. 4 terms factoring. 4 terms. So with this, we use grouping. Grouping, there's 3 steps right here. Let's pay attention to our 3 steps. First thing we do is we group the first 2 terms together. Right there, and the last 2 terms. So we've grouped them. Put parentheses. And then we factor the greatest common factor for each group. So an x to the third plus x squared, I kind of covered up the x squared. X to the third plus x squared can be factored out of that, which leaves what? X plus x squared. If we factor an x squared out of that, it's just 1, because x squared divided by x squared is 1. Now let's factor out of this. Negative 4, x minus 4. Well, negative 4 can factor out of both of them, but that's it. So if we take negative 4 and divide negative 4 out of it, that's just 1. So we have just an x. Negative 4, negative 1, plus 1, because we factored a negative 4 out of that as well. So now we factor the common binomial. What do you mean the common binomial? Well, I still have 2 terms. One of them is x squared plus 1. The other one's negative 4 times x plus 1. So what's common to both of them is they both have this multiplying of x plus 1. So that's one of our factors, x plus 1. And what's being multiplied by x plus 1? X squared is, and minus 4 is. So we factored it, the x plus 1 out of it. Now this is actually a difference of squares. We can change that to x plus 2x minus 2 in another step. But that's what we do. We factor the common out, and now it broke down to this factor. So let's try that with another one here. So let's put the parentheses around the first terms and the second 2 terms. We can factor out again. This is almost exactly like that one. We just have 9s instead of 4s. X squared, and this is x minus 1. This is a 9 plus 9, and that's x minus 1. So we can factor x minus 1 out of both of those, and what's left when we do that? That's left and that's left, because we took the x minus 1 out of both of those. So what's left is x squared plus 9. X squared plus 9. And that's as far as we can take that, because This is not a difference of squares. These are both squares, but this is a sum of two squares. So we're through with factoring that, because this would actually end up to be a imaginary number when we solve that. Let's do this last one down here. We'll just jump from that one to this one. So if we group these. Oh, there, I grouped it without covering any numbers up. Did better. Okay, what can we factor out of this? Well, we can factor a 2 out, and x to the 5th and x to the 4th. So they both have an x to the 4th. So when we factor out 2x to the 5th, we're factoring out 2x to the 4th from that. All that's left is an x. And when we factor negative 18 divided by 2, that's 9. X to the 4th, x to the 4th, yep, that's it. X to the 4th got taken out. It's just 1. 9 times 1. This one, we've got 7 that we can factor out of there. Let's take a positive 7. And what's it leave? It leaves x minus 9. X minus 9. So x minus 9 can be factored out of both of those. And that leaves us with 2x to the 4th plus 7. There you go. That's what it factors down to. And again, we started with an x to the 5th, so we should have 5 x's in our answer. Here's 4 of them, x to the 4th, and there's the 5th one. All right, so this is lesson 4.3. It's all about factoring. That ties right into section 4.4, solving. All right, solving involves factoring. We've got to factor it completely. First, step number 1, set it equal to 0. Move everything to one side and set equal to 0. 2, factor it as far as we can get it. 3, set each factor equal to 0 and then solve for x. So for quadratic equations, you can use the square roots, you can complete the square, you can use the quadratic formula, you can use difference of squares, whatever you can use to simplify that. So let's look at a few of them here on this first page, and we'll move on. So let me see, let me get my notes. Somewhere I've got some notes on which ones I was going to do on this. All right, let's start out with, let's start with this first one right here. X to the 3rd plus x equals 0. All right, this is already done for us. Number 1, everything's on one side and it's equal to 0. Everything's on one side. Let's factor that. Well, that'll factor to x times x squared plus 1 equals 0. This is already factored as far as it can be factored. So let's set each term equal to 0. So x is one of our terms. There's one of our answers. One answer is 0. Let's set the other term equal to 0. X squared plus 1 equals 0. So you got to subtract 1 from both sides. So x squared equals negative 1. If we have x squared equal and we want x, we have to take the square root. X equals the square root. Well, there's 2 answers there. Since we're taking the square root, that means there's a positive and a negative answer. So there's our other answer. Now, we've studied imaginary numbers. The square root of negative 1 is the same as I. So our other answers is I and negative I. So there's the 3 answers. I and negative I. So there's our 3 answers. Since there was x to the 3rd, we would expect there to be 3 answers. And there is 0i and negative I. All right, let's look at this one over here. This one starts out where it's 4x to the 3rd minus 7x squared equals 3x squared. First thing we do is move all the terms to one side, set equals 0. So if we subtract 3x squared from both sides, now it's 4x to the 3rd negative 7x squared minus 3x squared. Those are like terms, so we can say there's negative 10x squared. And now the other side is equal to 0 because there's nothing over there anymore. But these are like terms. We can't combine them with x to the third because that's different. But the x squareds can go together. So negative 7x squared is minus 3 more. So now we have it like this. So we can factor this. We can take a 2 out of it because 4 and 10. And we can take an x squared out of it. So when we factor that, we got 2x minus 5 equals 0. So set them both equal 0. 2x squared equals 0. And 2x minus 5 equals 0. So 2x squared equals 0. Well, x, we divide both sides by 2. It's x squared equals 0. Take the square root of both sides. The answer is just 0. And actually, there's 2 of them. We won't have to put them both. And over here, we add 5. 2x equals 5. Divide by 2. So another answer is 5 halves. So there's our answers. 0, 0, 5 halves. So really, it's just 0. There's a multiplicity of 2, but the answers are 0 and 5 halves. Knowing the multiplicity of 2 tells us there's 3 answers for that. So, all right, these work the same way. Let me see if there's anything drastically different back here. Yeah, here's one that had 4 terms this way. See, x to the third plus 2x squared plus 5x plus 10. So that one, we would need to factor it with the grouping. X squared times x plus 2. And then over here, we can factor out a 5, and that would leave an x plus 2 equals 0. X plus 2 is the one we factor out of both of them. That leaves x squared plus 5. Now we've got it factored as far as we can go. So x plus 2 equals 0. X squared plus 5 equals 0. Subtract 2. X equals negative 2. Subtract 5. X squared equals negative 5. So this is going to be x equals plus or minus the square root of negative 5. So that's going to be an imaginary answer. But that is the other 2 answers. We got negative 2, positive square root of negative 5, and negative square root of negative 5, which is 3 answers for the x to the third. So that is it. Let me show you what our assignment looks like. Here's our assignment. It's loading slowly, as it does. All right. Solve. Well, the first ones are up here. The first ones are just factoring. So give me the factors of that after you've fully factored it. All right. Check for a greatest common factor and factor it. After that, solve it. So this is where I just put the answer. Like on the ones we looked at, okay, the answer was 0 and 3. That was, and let's say there was 2 3s. That's the x to the third. That's just guessing, but all you need to do is put the answers of what x equals on the ones that say solve. So you have 12 all together. We'll delete that because that's not right. I just threw it up there as a guess. All right, that should be it. I know that was about 40 minutes of going through all kinds of good stuff, 35 minutes. If you got questions on that, bring them. This week is B day, so we only have Wednesday for this class if your grade's below 70%. And I'll let you guys go. If you got questions, you can hang around.